Right, let's start this video then with two questions. First question, would you rather have a bowling ball thrown at your face or a tennis ball thrown at your face? Secondly, would you rather have a speeding bullet fired towards you, or would you rather have a small rock fired towards you at a slower speed? Well, most of you will probably say, firstly, I'd rather have a tennis ball thrown at my face, because it will hurt less. Likewise, you might have said that a small rock being thrown at you rather slowly would hurt a lot less than a bullet hitting you, which is, makes sense. So this is all because of momentum. Bowling ball has a lot more momentum than the tennis ball. The speeding bullet also has a lot more momentum than the small rock. So let's think about momentum then. Momentum, I like to think of momentum as how difficult it is to stop something from moving. It's very difficult to stop a bowling ball from moving compared to a tennis ball, because the bowling ball has more momentum than the tennis ball. It's very difficult to stop a speeding bullet compared to a small rock, because a speeding bullet has a lot more momentum than a small rock. Okay, so let's think about the things that affect the amount of momentum that an object has. Firstly, in the bowling ball and the tennis ball case, the bowling ball has momentum because it has more mass than the tennis ball. So the mass affects it. Okay, so more mass. So the bowling ball has more mass, therefore it's got more momentum. And by the way, we're assuming that both of these objects are going to be travelling at the same speed. And in the second case, if you've got a speeding bullet and a small rock, the speeding bullet has more momentum, not because it has more mass. Okay, we're going to assume that they've both got the same mass, but the speeding bullet actually has a much larger velocity. So let's get the velocity. Okay, so for two objects with exactly the same mass, the faster of the two objects will have the largest momentum. For two objects moving at the same speed, the heavier, the more mass the object has, the more momentum it's going to have. Okay, so now we can get ourselves a very good definition for momentum just from these two things. So it depends on the mass and the velocity. Therefore, our definition for momentum will be the product of mass and velocity. Yeah, so we can get an equation from this. Momentum equals mass times velocity. Okay, so there's our equation. Momentum equals mass times velocity. Momentum, well, let's go do some unit analysis on this to find out the unit of momentum. So mass has the unit kilograms. Velocity has the unit meters per second. So what's momentum going to have? What unit is momentum going to have? It's going to have the unit kilogram, because it's mass, times by meters per second, velocity. So it's kilograms meters per second. Okay, there's our unit for momentum. That's an equation that you need to know for your AQA GCSE. Right, if you want to, you might see this written in this way. So you've got P, M, V, like that. Okay, so you've got, weirdly, okay, we have to represent momentum with the letter P, because M is already taken up by mass. So momentum on the top. Okay, there's our formula triangle if you want a formula triangle. So here's a couple of questions we can look at then. So have a go at those and then unpause the video and I will go through them. Okay, so let's go through question one. So remember, momentum is mass times velocity. So if we're trying to work out the momentum of a 1,500 kilogram car travelling at 20 meters per second, all we need to do is take the mass of 1,500 and multiply it by the velocity of 20. And you get an answer. 1,500 times by 20 gives you 30,000. 30,000 kilogram meters per second. Okay, there's your answer. The second one then, so we've got a bullet with mass of 0.01 kilograms and it's moving at 300 meters per second. And a rock with the same mass is moving at 3 meters per second. How much more momentum does the bullet have? So let's start by finding the momentum of the bullet. Okay, so the bullet has a mass of 0.01 kilograms and a velocity of 300. Okay, so we times them both together, you get 3 kilogram meters per second for the bullet. Right, now the rock has got a mass of 0.01 because it's got the same mass. We're going to times it by the velocity of 3 and you should get 0.03 kilogram meters per second. So in order to work out how much more momentum the bullet has, you just have to take 3, which is the momentum of the bullet, and subtract the momentum of the rock, which is 0.03, and you get an answer of 3 minus 0.03 gives you 2.97 kilogram meters per second. Okay, there we go. Right, I will see you in the next video.